Some physics problems look impossible, right? But what if there's a clever shortcut to the answer?
Okay, let's take a look at a classic problem. Seriously, where would you even start with this? Well, you could use F equals ma, but trust me, that is the long way around. Instead, physicists use a more direct route. It's built on two key ideas we should probably define. First up is momentum. Think of it as how much oomph an object has, its unstoppability. And then you have impulse. That's the push or pull over time that actually changes the momentum. And here's the magic. The principle is super simple. The impulse equals the change in momentum. All right, let's take this back to our problem. First thing we do is map out all the forces. Now, check this out. We can use one single, powerful equation that connects everything we need. So we just plug in the numbers we know, the weight, friction, all of it, right into the formula. And just like that, we get our answer. See how clean and fast that was? But this approach isn't a silver bullet. What about problems that don't even involve motion? Right. It turns out there are different shortcuts for different types of problems. Makes sense, doesn't it? So on the left, you've got things moving. On the right, things are static, totally balanced. For these static problems, there's another really elegant shortcut, the principle of virtual work. The basic idea is this. If a system is perfectly balanced, any tiny imaginary nudge does zero work. And this makes solving for forces in really complex mechanisms, like this one, way, way simpler. So what's the big picture? These aren't new laws of physics, just much smarter ways to apply them. The point is, these principles are awesome problem-solving tools. They turn messy calculations into elegant solutions. So it kind of makes you wonder, right? What other elegant shortcuts are just waiting out there to be used?